Hi, welcome back to China Manufacturing Decoded from the Sofeast Group. Adrian from the team at the wheel here, and Andrew Amirnovin is joining me today. Andrew, hello.
Hey, Adrian. Good to be here again.
Yeah, welcome back on. I really enjoy doing these episodes with you. And we kind of get a real sort of engineer's viewpoint on different topics when you're on, which I think is helpful. And today's no different. This is episode 178. And today we are talking about component testing.
Yeah, I think this is a good topic for either a mid-sized company or an entrepreneur that is interested to learn about, components and how to make sure that they don't have any issues, components related once they launch the product. So this is definitely the episode for them.
When it comes to component testing, right, I think let's start by just introducing what does this term mean? We know what components are, of course, but I think it's important to explain.
Yeah, good question. I think that maybe I should kind of explain to our listeners what the difference is between component level testing as well as product level testing.
Yeah.
When you are testing the product, you're looking at the product performance as a product, not individual components. So, let's take your mobile phone, for example, as an example. So your mobile phone, while you're holding in your hand, its function is to actually call somebody, right? So testing the call is what you want to do. You basically want to test the product, make sure it's still calling and it's turning on and making a phone call, even after do some environmental tests like high temperature, low temperature, or vibration test, or even drop test from 1 meter. You want to make sure that this product as a whole, it's still functioning within specification. So that's product level testing. Although, as you go through the design and development, some of the actual functions that happens in design and development phase are almost identical. For example, you're doing DVT, design validation testing on the product. In some cases, if you were the component design and development company, like the supplier who actually designs that component, they probably have to do almost exact same thing because their product, right? Their product is the component. So, their packaged product is the component. So that component has to go through series of environmental reliability, compliance, and basically a whole bunch of even manufacturing tests. All of these have to be very similar to if you had a big box product with a whole bunch of PCBs and components inside. The process is almost identical, but individual components, when a designer is choosing in order to place it in their product, then all of a sudden there are differences slightly. Now, what we're going to discuss today is not the product level testing. We're going to talk about the actual component level testing. Now, component level testing really can be divided into two areas. One is PCB level testing or PCB testing. That's where you've got the PCB and you've got a whole bunch of components on it, and you just want to know how the PCB is functioning. Of course, design engineers hook it up usually to analyzers of different kind, curve tracers, oscilloscopes, network analyzers, and they want to know the voltage in, voltage out, current in, current out, input and output voltages and currents, and also the curves that are supposed to be. So they test all these specifications based on the design, and they would like to see that those specifications of the PCB remains the same after going through any kind of environmental testing, right? So that's called PCB level testing. Then there is the other side where you take a component out of the PCB. Now, any component, let's say, for example, a resistor that belongs to a particular supplier, and maybe it costs $1. I'm just exaggerating here. Actually, resistors are typically cheap. But let's say it's $1, and then another supplier is 50 cents. Well, if both of them actually perform exactly the same to your satisfaction, why would you buy $1 version, right? So you want to go with the cheaper option. And for that reason, the design engineer would like to kind of swap these parts and look at the performance and make a determination. Yeah, I think the 50 cents will do. Let's just choose that version, right? But they will do that with a whole bunch of components, right? So let's say you got 100 components and each one of them have 2 sources. And then what are you going to do? You're going to be testing 200 parts, basically, right? To make sure that all of them are meeting or exceeding your performance goals, specification goals, and then some. So that is what we're going to basically focus on, talking about how to go about doing component testing in general.
Okay, good. So we're doing component testing then, first of all, at a much earlier stage in product development than the product level testing, of course, because the products has been put together by the time we're testing, prototypes and different samples like that. Would you say the component testing is kind of like a type of incoming QC as well?
Well, there are elements of incoming QC, sometimes we call it IQC, that has component testing in there. And again, it's more of an inspection type of testing. A lot of times these component tests are not necessarily functional, but sometimes they are. So yes, it's more like sample inspection tests, just to make sure that the sample size that they have, which represents a sample of a lot that the company or the customer is receiving, is going to meet or exceed basically the requirement for that product.
Okay. Yeah. So, quality is one aspect of it. You spoke about engineers and they're trying to assess what is the best option, or maybe, what is the best option at the right price for the product. And this is going to really help them make that decision. I get that. And I can see why that's important. So before we go into the sort of testing structure for components, talk to me a bit about the component qualification process, please.
Yeah, so component selection is a major task. Typically, you have several people involved in actually getting this task done. One of them is the design engineer, who basically really initiates the process. He basically requests from purchasing and component engineering that, hey, I need this particular component with this type of specification. So, for example, let's say the design engineer comes in and he says, I need this 2 microhenry or 2 microfarad capacitor, right? And then that request goes to purchasing, and the purchasing comes up and says, well, I can definitely get some samples for you from 2 different suppliers. And design engineer, of course, is happy. Yes, definitely. When and how much, right? So the purchasing agent actually gets some samples and they quote some price. So as I was saying, when we're talking about the component selection, the supply chain individual will actually try and get some more volume pricing as well. And so you've got 2 suppliers, and that's when you get components engineer involved. So component engineer tasks are whole bunch. One of them is the fact that he has to help actually qualify and test his product. One way is going through the data sheets and making sure what's inside the data sheet for each component actually matches what is required per specification for the design. So that is the first thing that they will do. The second thing is they want to make sure that this component, it can be produced in high volumes by the supplier. So what they do is typically make a plan to visit the supplier and do a supplier audit. And in that team, supplier audit team, typically there is a design engineer who is actually responsible for that design and is going to use that component. Then the component engineer, purchasing manager or purchasing individual. And then sometimes you have a quality person as well. They go actually visit the supplier. And there's a whole bunch of supplier audit process questions that comes up, and they ask from the supplier to make sure they're capable suppliers and they can actually meet the price, the quality, the volume requirements, and a whole bunch of other, like expansion requirements and so on. So once the process audit has been successful, then the component engineer will probably do a couple of things. We'll ask for some samples, and depending on what it is, if it's an IC, he may probably ask for a whole reel, like one reel of that product as a sample.
Mm-hmm.
If it's caps, resistor, or some other type of connectors and so forth, he'll probably get some kind of samples. Usually at least like 100 samples or so. And then some of those samples gets distributed to designers, sometimes for other test labs or in-house test lab. And then maybe one or two, the component engineer will keep it as evidence. And then one or two, he will break it down and do some, they call it cross-section analysis, just to evaluate the product in terms of what's inside, how is it made, and so on. And then they might even, in military contracts, they'll send some of these to outside test lab to do, for example, on the ICs, they'll do a bond pool and some other tests to make sure that these are designed and built reliable and environmental factors are not going to actually fail the product easily. So there's a lot of activities goes on. And as the component engineer will also assign some temporary part numbers for these because they're not really approved yet, but they need to be tested within the product by the design engineer. So usually the design engineer will do the initial test on the actual PCB, and they will, monitor and check the performance of that part live while they're actually designing on the PCB. They'll monitor it in terms of, for example, specification and voltage and current measurements and some other measurements, on scopes and so on. Once they do that and they're happy with the part, that's when the component engineer will actually take that, for example, reel of that part, and he will do a what they call component pilot run, and he'll take that to actual manufacturing. And in some ways, you can say that is a manufacturing test. So then once that reel of the, let's say, component samples have already been built into the PCB, a sample of those PCB comes in, back to the design engineer, and they're labeled, So, for example, a design engineer will say, okay, which PCB is this one? And component engineer or someone who's working with the component engineer will say, hey, this one has this particular component from this supplier, but this other PCB has the same component from a different supplier. So he'll take those and test them, and he'll come back and say, well, I didn't like the specs or the performance of this PCB with this supplier, but I like this one. So basically, you disregard that supplier because you know that it didn't meet the specification. And then the one that met, that's the one that goes into further testing. And that further testing is reliability testing, basically quality testing, manufacturing testing, whole bunch of other tests that goes through to qualify that component. And once that component is qualified, then it gets an official internal part number that is assigned to the manufacturing part number, so that, you know, if that internal part number is designed into any project, then you know which manufacturing part needs to be purchased. Does that make sense?
Yeah, it does. Great. Thanks. That's good, Andrew. So now we know about qualifying components. That, of course, is important to be doing that as we're trying to select the right ones. There is a component testing structure that you've outlined, and you alluded to it in this section that you were just talking about beforehand. There's about 10 points that you can take us through, right? I know you've already discussed number one to a degree, which is component selection, but yeah, if you just kick it off from 1 through 10.
Yeah, so if we were talking about just in general, you know, component test, and maybe we should call it component test and evaluation process. And in that sense, yes, component selection is number one, which also entails component supplier selection and audit, and also understanding, you know, component specification and availability, for example, in terms of volumes and so on. So that is very important. But number two would be more of a component data sheet analysis. And that means that, okay, there are stuff in the data sheet for every component. There are specifications, there are charts and graphs, there are temperature requirements. This is really, really important. You could be you could be picking a component that in the data sheet, without going through too much, you could say, hey, you know, this meets exactly my requirement. But if you don't look at the data sheet a little bit more in depth, and for example, thermal requirement, you know, temperature requirement, and then all of a sudden you realize that, oh my God, you know, our product is going to be, you know, used in a very hot environment, and this component will definitely not last in the hot environment. So every component has a data sheet, and in that data sheet, it talks about not only specification, voltage and current and operational level or max voltage and current, but also thermal, reliability, environmental, whole bunch of data that, just believe it or not, every design engineer needs to pay attention to every one of these design elements. And this is where, honestly, I think that most design engineers are underrated, and because people, even project managers, don't realize what the design engineer has to do to pick the right product. I mean, some of these component data sheet, I'm not kidding you, they're like 30 pages. And if you're a newbie design engineer, you really have to pretty much go through the whole 30 pages of the data sheet for that one component alone. And imagine you have 100 components on that product. And that's why you typically have a senior level design engineer who already knows those 30 pages. And he says, yeah, just look at this one page, and the junior level will follow him. Otherwise, if you're new, that product is not going to be. We were talking to a new customer a few days ago, Adrian. I think you'd be interested in this, kind of relates to what we're doing. And the customer said,
yeah, please.
Yeah, the customer said that their product took like more than 3 years to develop. And it's not a unique product, honestly. And, you know, when they're going from one iteration to like an upgrade version of the product, it's still taking them, you know, between 2 to 3 years. And one of the things, the key elements that I caught on as they were explaining how they do the business, is the fact that they are not very senior level design engineers. And this is where it's like they're learning what they're doing as they are designing this thing, and that's why it's taking so long. And they were saying that Huawei and some other Chinese manufacturers already got a version similar to what they're making already. And that's understandable in some cases. So my point is, this is not to make a note to any customer or anything. That it's just that it's very important for these design engineers to be understood that it takes these poor guys a long time to figure out if all the specification on that data sheet for that component actually is going to meet his design requirements. And God forbid if he makes a mistake. I mean, everybody's going to be like, oh my, you don't know how to design this thing. So it can be really unfair, I'm just trying to say. And then, of course, number 3 element is visual inspection. A lot of times, some of these components are manufactured in a way that they go through a lot of, let's say, cutting and painting. And so depending on what the product is, what the component is, sometimes the packaging and so forth. So it's very, or like the pin alignment, like if it's an IC, the pins, there's too many pins in there. And if the pins are not aligned, someone needs to kind of have a visual check on those and before they go to production or before they're being used in any design. So physical damages, or manufacturing defects. So visual inspection of these components is like the first thing that I think that most design engineers would do or quality engineers would do. And then, of course, number 4 is the continuity check. This is where certain components, maybe you need to have a continuity check, like resistors and some inductors as well. Sometimes some transformers, you do continuity check. This is really critical because what if you ask for 1 ohm resistor, but you're not getting 1 ohm? You're getting high resistance than 1 ohm that you ask for. And sometimes the design is very specific and you can't have variations or too much variations, and you have tight tolerance on those resistors. So continuity check means, you're checking to see if the resistance is within the limits of the specifications and so on. So you might, like you said, in IQC incoming inspection, they might be taking some samples and making sure that it's within the spec. And then, of course, number 5, functional testing. This is a little bit different than performance testing, the number 6. Functional testing usually means you plug it in and it looks like it's working. Now, whether it's working within the spec or not, sometimes that's not important. You just want to make sure it's working. Whereas performance testing is not only it's functioning, but also it's functioning within the voltage, current, temperature, frequency variation, and basically it's going to work certain boundaries of the performance that you require that product or component to work. So that is that's the main difference between performance. Performance testing is pretty much critical. It's kind of like you plug in the light bulb and it works. So that's the functional test. Yep, it's working. Now, if you take that light bulb and you increase the voltage a little bit or increase or decrease the current, is it gonna make a difference? And is that acceptable or not? That's the performance testing. And then environmental testing, of course, this is related to some sort of reliability. For example, temperature conditions, humidity conditions. What if there is a vibration or shock? Is the component going to fall off the board if there is a big vibration, right? And so those are like, you and I have discussed ISTA 2A test, right? Package testing during transportation, and this vibration and the dropping of the package can actually sometimes impact the product in it. And what if, for example, one of the components wasn't soldered well, and as soon as you drop it, boom, it'll just break off. And now you've got a loose component that not only perhaps could be a short for the rest of the product, but also it's going to have some kind of errors or maybe even completely not function because that component is broken. So environment testing is important, and one of them is transportation testing. And then number 8 is the aging and life cycle testing. This is one of the important things as well, because let's say you're building a car, right? You're designing a car. Most cars must function, at least operate for 10 to 20 years, in some cases 30 years. What if your component that was selected or designed can't handle 30 years? Like, for example, in 5 years, all of a sudden they're breaking. Well, that would make the car unreliable, in some case, maybe even unsafe for driving. And there is a good chance that, as soon as you have major failures and somebody got seriously injured, that's it. No one is going to buy your product. So aging and life cycle testing on the component is critical to ensure that each and every one of your components that are going to be designed in your product actually meets your product reliability goals as well, and life cycle and aging goals as well. So that's one of the important things.
Okay, so just jumping in here, you've been through a number of the tests. Number 9, I can see is coming up, is compliance testing. This is it's a big topic in and of itself. You've spoken about doing compliance testing on products before. So what's compliance testing on components like?
Compliance testing for components is just as important as the product level. I mean, take an example, a battery, which is a component. It needs to be going through all sorts of component testing. For example, there is a thing called UN 38.3. I believe that's the right number. That is kind of a battery transportation approval process. Basically, the battery has to go through a series of tests to be certified the fact that, it's safe. This battery is safe enough to be transported. So that's just one component and one certain test. But then there are other components, like, for example, certain radio frequency products, that they have, for example, RF chip inside, like a Wi-Fi chip or a Bluetooth chip. These products have to go through FCC testing. And, basically, we're talking U.S. market. In the U.S. market, and there are some other countries that they have different requirements for, similar to FCC. But in U.S., every radio frequency generating component, like a Wi-Fi chip or a Bluetooth chip, must go through FCC testing and approval, meaning that FCC has some certain guidelines on frequencies that these Wi-Fi chips and Bluetooth chips produce, and these requirements really are geared towards protecting one equipment that is generating certain signal from another equipment, so that these equipments don't jam each other's frequencies. It's almost like you and I talking at the same time, and that's not a good thing for us, right? So you want each component or product to be basically producing these frequencies in certain authorized channels, so that they don't interfere with each other's functionality or performance. And so these components, although it's just a component, but they must go through a whole bunch of compliance requirements. In the case of Bluetooth, they have to go through FCC and a whole bunch of other countries' requirements, depending on the market. In terms of transformers, they have to go through some other tests. And what if you have, for example, an adapter that you have to use for a home use? Sometimes they have to go through UL testing, which is another safety type of requirement. So yeah, the compliance is for components is just as important as compliance for product level.
Oh, sure. Absolutely. Yeah. Compliance is always really key. So, and the last one, number 10.
Yeah, number 10 is documentation. Now, let's say you have a component engineer in-house and he is managing a components database, which actually component database has two parts. Usually one part is, new parts that he is actually reviewing and deciding whether or not, he's going to approve. And then there's another database, basically qualified components database. And that sometimes they call it approved vendor list, which is not exactly the same as, they're not exactly the same, but let's break that down. Let me go backwards actually on that one. So the way it works is that you have a components that are approved. So he will issue approved part numbers, internal part numbers. But then sometimes that particular one component, internal part number, will have several suppliers, several vendors. So let's say there's one part number, it means, 100 ohm resistor, right? This 100 ohm resistor will have 5, sometimes, or 6 vendors, but then you'll have 2 of them approved. So you have all these 5 available suppliers, but only 2 approved. And you really don't want to have a whole bunch of suppliers for your products. Usually 1 or 2 is the best. 2 is better, just in case it's a CTQ component, because if it's critical to quality component, like for example, a type of component that if it breaks, the system goes down, or if you don't have enough of it, the volume, then that whole product can't be used, can't be sold. And if that's the case, you probably need to have 2 suppliers in case one can't produce or provide, then you go with the other one. But most supply chain, purchasing managers, they usually try to have just one supplier, because when you add up the volumes that you buy from one supplier, if they're reliable, if you are not foreseeing any kind of a shipment issues from that supplier, then going with one supplier is actually good, because you get a much better deal in terms of pricing, because you're going with heavier volumes, right?
Yeah.
But second sourcing is also important if the component is a critical to quality component. So you do all that, and so you need really 2 types of documentation. One is documentation in the database format, which is approved components and approved suppliers. But then you also need approved data sheets. That means you have an internal data sheet for that particular component. That means that, yes, there are many suppliers for this component, and each one of them are slightly more or less, but the internal data sheet basically draws the limit, draws the line. What's the maximum current? What's the minimum current? Basically the size and the shape, form factor, specification of performance. So all of that is spelled out in the internal data sheet, which is very important documentation. So, keeping track of approved suppliers, auditing them, annually or biannually, depending on the volumes you have. And then regularly adding new suppliers in case, your volumes and your product are increasing in sales. So it's just a continuous thing that the team basically overall needs to do to keep the product moving towards the right direction.
That's a good summary of the sort of 10-step component test and evaluation process, Andrew. And if you're listening thinking, oh, wow, this is quite complex, and this is just component testing, what about the rest of the product? Well, I guess you'd agree. Bringing a new product to market, nobody said it was going to be easy, right?
Yeah, it really there's a lot involved, and then I think that our listeners get a real appreciation for design engineers, component engineers, reliability engineers. They are incredible contributors to the design team, which I think, honestly, the product and quality engineers, I don't want to forget that. Without these design and the support team, on the quality design, on the reliability, on the purchasing side, on the component engineering side. If you don't have that design support team, I am sure that the product will have all kinds of issues at the end.
Yeah. Yeah. Spoken like a true engineer, though, Andrew. I like it. I suppose you'd agree, especially maybe with some SMEs, you're not going to expect them to have a full complement of this sort of expertise in-house, are they?
Yeah, I mean, honestly, you said it right. And when we get approached by a customer that wants us to design everything from scratch, which we get that a lot,
Yeah.
we basically go through this whole process. We go through several vendors that we think could be ideal vendors. And then we go and literally with a whole team, and actually do an audit and decide whether or not they're going to be able to actually provide those samples, the right kind of specification. Then we get some samples, start working with one or two of those, and then we go through qualification of those through our design engineers, component engineers, and reliability engineers. And then once we have those turned into a product, then we do either component level testing or component testing, individual component testing. And then we go through this whole process that we just explained until it becomes a product. Once it becomes a product, then we have internal labs like RSQ labs it's our own lab that can do a whole bunch of testing, including halt and has, including vibration testing, drop testing of product level, package level tests like ISTA 2A. And so we do all of these tests, and then once we have the results go through product analysis, reliability engineering team and design team meet and decide which components failed or what was the root cause of those failures, and then corrective actions need to be applied. And then we go back and do another test to make sure that those issues are not seen again after the fix of the problems. And then once everything is good, then we move on to mass production. And then, of course, we do compliance tests before mass production once the design has been frozen. And those compliance tests, some of which we do ourselves, some of it we work with our partner labs that are authorized and are certified body by either UL or, FCC and so on. So we really take the whole product through the entire product design and development lifecycle, and a whole bunch more that goes on that it's really hard to explain all in one hour.
Sure. I do have a question at this point. So far, you've spoken about components that would probably be used for electrical or electronic devices or products, right? So you've alluded to things like resistors, PCBs, and other electronic components like this. But when we talk about component testing, actually, this could be on non-electrical components as well, right?
Absolutely. I'm glad you brought that up. Yes, it could be like, for example, screws, nails.
Yeah.
It could be sheet metal. It could be plastics. We do basically almost the same exact process for even non-electronic and mechanical motors, for example. Yeah, we do all of this for just about every materials. We even do some material analysis. We just bought, for example, Instron type of machine. There's all kinds of material analysis. Yeah, we have all kinds of capabilities, and this whole component testing is not limited only for electronics. Thanks for that. Good question.
Right, right. Okay. And so as we come towards the end, then, I think based on your experience in the industry over these years, you've got some examples of problems that might occur if component testing is not done correctly. And I think that's going to be super interesting.
Yeah, I think it was a while back that, for example, a screw went bad in an airplane. Can't remember which airplane. It's been a while, so I can't specifically mention it. But yeah, the airplane went down because of the screw broke. Or sometimes we've heard in the news, certain elements of the airplane can't function well because of the icing. So all of these have to do with probably components and materials testing. So if you've done a really good job on these, then you probably have known or should have known that this particular, for example, screw is not going to function well at a certain temperature, or maybe even crack and break. Have you ever, taken a coffee mug, and poured a hot water in it? You see what happened, right? Some coffee mugs will just crack.
Well, yeah.
Yeah, it's that kind of a test that you have to actually do in certain components to make sure that you're getting a kind of a coffee mug that is not going to crack as soon as you pour hot water in it. So component testing is critical. The Titan submarine, that the recent issue that we saw, that had a lot of component issues that basically components that were not tested. I heard, now I'm not quite sure, but I heard that they used a remote control, not a remote, but like a playing game controller, like a video game controller for steering. I don't know if that's true or not. That would not be a good idea. Certain components on that submersible, I heard that were not actually, tested and didn't go through any kind of regulatory testing in terms of compliance to oceanic regulatory process. So, it's hard to tell if each one of those components actually went through any kind of engineering level testing. So it is really, really, I just have to mention that component level testing is crucial for quality and reliability of the product. And unless you have done thorough component level testing, or making sure that at least your supplier has done thorough component level testing, and the specifications that the supplier has on the data sheet are actual and real data, and no fake data, then you can trust that if you do the right types of reliability testing on and environmental testing on product level, then most likely you're going to have a reliable product at the end.
Right. And talking about testing, it's impossible in this podcast for you to outline the kinds of tests that will be done per component, because for every component, it's probably fair to say that every component that you might require for your product probably has its own kind of unique testing that would need to be done to it. So you can't, outline a list, for example, but you've spoken about the types of testing. So we got functional testing, performance testing. But would you say that when we are looking at the tests for the specific kinds of components for our product, when we engage, let's say, a testing lab, okay, if I'm an importer and I am not an expert in the type of component, can I rely on the testing lab to select the right types of test for the component that I need, or do I need to do some sort of homework as well?
And so it depends, right? So let me start from discussing the fact that you mentioned that there are different kinds of components. You've got displays, you got vibrators, you got resistors, caps, inductors, and then you got materials. So you got a lot of these components. And each one of them, the way you test For example, a display is not the same way you test a resistor and caps and inductors.
Right.
So typically, on the development and design phase, we engineers rely on the supplier having done just about most of the component level design tests and performance tests. So the part that we verify usually is a component limit testing. Like, for example, the component says that the component data sheet, says that this component can handle, for example, 85 degrees C, right? And possibly minus 10 degrees C. So from product performance point of view, we know that the product, this component works in our design and it's given us ideal performance. But what we don't know, what if the temperature freezes? Minus 10 degree and your car is using this component and it's parked outside. Am I going to be starting this car because of this component or not? You see? So it could come down to that point, and that's when typically on the design and development side, you don't have to do all of these specific tests that are geared for manufacturing and design of the component. So usually you push all of those tests back to the supplier, and all you do is, hey, is this component going to be in par with the environmental and reliability level of my particular product? And so if it's not, believe me, our reliability engineers will catch not reliable components. We will find it.
Okay, yeah, that's good to know. So there we go. You've explained what components level testing is, the difference between component testing and product level testing, the component test and evaluation process, and given some examples of problems that you're going to encounter if you don't do it correctly. That is a great bit of guidance to component testing, one of many things that we need to do when we're developing a new product. But hopefully now, if you've been listening from the start, you'll have a good idea of what it is that you need to do and why. So thanks, Andrew. It's been good having you on again.
Absolutely. Thanks, Adrian.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.